Alrighty folks, today we're looking at properties of the vertex form. First things first, we have again our a value, that's going to be our coefficient. And the coefficient is still going to cover our steepness and our direction of our quadratics, just like it did for standard form. We also have our h and our k, and our h and k makes up our vertex, the x and y coordinates of that vertex. Additionally, because the equation gives us h and k, we automatically know where the axis of symmetry is because that's going to be our h value. So the axis of symmetry is equal to x equals h. Those are the big things we need from vertex form. There's not a quick roots method for vertex form, so we're just going to ignore any root questions for us. So in these 5 problems, we're going to go through and identify the vertex for each equation. In the first one, x minus 1 squared minus 6, our vertex is at hk, so that's going to be 1 comma negative 6. Number 2, negative 2 times x plus 5 squared minus 2. Here's our h value. Remember, our x's lie to us, so we're going to have negative 5, negative 2 as our vertex. Number 3, f of x is equal to 3 times x plus 2 squared plus 3. Our x's are aligned to us, so we've got that negative 2 and that 3 for our vertex. 4 and 5 look a little weird. In 4, we don't really have an h value, except we do. In mathematics, adding or subtracting 0 is oftentimes not represented because it has no effect on the actual equation itself. But we can think about number 4 as x minus 0 squared minus 1, indicating that 0 is our h value, and negative 1 is our k value. Number 5 works a similar manner. We don't have a listed k value, but technically we're adding 0 to it. So our h value is 1 and our k value is 0. So pulling out the vertex from our vertex form equations. All right, so graphing in vertex form. We want to graph f of x is x minus 3 squared minus 3. Right off the bat, our axis of symmetry is going to be our h value. Our h value is x equals 3. Our vertex, that's our h and k, so that's going to be 3 comma negative 3. The y-intercept occurs whenever we have x equals 0. So we're going to plug in 0 for x to solve our equation. F of 0 is equal to 0 minus 3 squared minus 3. F of 0, well, 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 3 gives us 6. So our y-intercept occurs at 0, comma 6. And roots, we said we're going to ignore roots for vertex form. Now right off the bat here, or so far here, I have enough information to make a general sketch of my parabola. Because I know that my vertex is at 3, negative 3. I have a y-intercept at 0, 6. Connect my dots as best I can. I have a parabola that opens upwards. I also know my parabola opens upwards because my a value here, that it looks like it's not there, but we technically have a positive 1. A positive 1 means that we're going upwards. Domain, all parabolas have a domain of negative infinity to positive infinity. Range, this is my y values. My vertex is my minimum. So my range is going to be from negative 3 to positive infinity. Bracket on that negative 3. My interval of increase and my interval of decrease are both going to be based on my x's. My interval increasing runs from 3 to infinity. 3 is not included. My interval decreasing runs from negative infinity to 3, also not included. Because 3, x equals 3, is our minimum value. At x equals 3, our graph is neither increasing nor decreasing, it is merely at the minimum. And that's our first problem. Second problem, we want to do f of x is equal to negative x plus 1 squared plus 4. Our axis of symmetry is going to be x equals negative 1, because it's going to be the h value. In this case, the h value is negative 1. Our vertex, negative 1, comma 4. Y-intercept, plug in that 0 into my equation, and I'll get my f of 0 is equal to negative 0 plus 1 squared plus 4, which means that f of 0 is equal to negative, well, 0 plus 1 is 1, 1 squared is 1, so negative 1 plus 4, which comes out to be 3. So my y-intercept is going to be 0, comma 3. Roots, again, we're going to skip that because there's not a clean way to get them. So let's go ahead and sketch what I know. I've got my vertex at negative 1 up 4. I have my y-intercept at 0, 3. Connect my dots as best I can. I know my parabola opens downwards because of that negative a value. For my general sketch, domain will be the same for all my parabolas, negative infinity to positive infinity. Range, here the range is going to look a little different than the previous ranges, so we always start from the lowest number. Our lowest possible y value is negative infinity. Our highest possible y value is 4. Increasing interval, again, our increasing and decreasing intervals are based off our x values. So our increasing interval, we go from left to right, so from x equals negative infinity all the way until x equals negative 1, we have an increasing interval. So negative infinity to negative 1. The decreasing interval got cut off, but it would just be from negative 1 to positive infinity. That's number 2 for us. Last part of this, write a quadratic equation given the vertex and another point. This is why I love vertex form, because it's so easy to build our parabolas as long as we know the vertex and one other point. So we're going to determine the quadratic function whose vertex is 1, negative 5, another point of the graph is 0, negative 3. We're going to use our vertex form equation of f of x is equal to a times parentheses x minus h squared plus k. First things first, plug in my known values of my vertex. So I've got f of x is equal to a times x minus 1 squared minus 5. Next, I'm going to plug in my secondary values to solve for my a value, because I know that f of 0 is equal to negative 3. So if I'm going to plug in 0 for my x's, I then get negative 3 is equal to a times 0 minus 1 squared minus 5. Simplify this out. Negative 3 is equal to a times, let's see, 0 minus 1 is negative 1. Negative 1 squared is positive 1 minus 5. I got to move that 5 over. I'm going to add 5 to both sides. And that'll give me 2 is equal to a times 1. But as covered, multiplying by 1 doesn't really change anything. So we can just move that away, divide both sides by 1 if we want to, we get a equals 2. I'm then going to take that a equals 2 and plug that back in to my purple equation here. This will give me my answer that f of x, the equation of that parabola, is equal to 2 times x minus 1 squared minus 5. And that, folks, is the end of these notes. If you have questions, please come to tutoring. Please ask those questions via email, come to flex time, so we can work on this topic.